You live in a world where millions of things are made every single day. Your car, your mobile phone, your refrigerator, even the machines that build other machines. But have you ever wondered how the giant robots that work day and night in factories are actually built? And the bigger question, do robots that build other robots really exist? You'll be surprised to know that in some of the world's most advanced factories, robots outnumber humans. From cutting steel to welding, painting, and assembly, machines do it all. But there is also a factory that builds these machines, and this is where engineering, automation, and artificial intelligence come together in the most amazing way. But the real story is just beginning.
The story of an industrial robot doesn't start in a computer lab. It begins with metals and rare minerals. High-quality steel and aluminum are used to build its body. These metals don't come straight to the robot factory. Their journey starts in mines, where massive machines extract iron ore from deep inside the earth. The ore is sent to steel plants, where it is melted at thousands of degrees. Impurities are removed, and strong industrial-grade steel is prepared. This same steel later becomes the robot's arms, joints, and main frame. But metal alone is not enough. The real brain of an industrial robot lies in its electronic systems. It needs microchips, sensors, servo motors, control boards, and high-speed processors. All these components have their own factories. Some microchips are made in clean rooms so pure that even a single speck of dust can stop production. Once all the raw parts are ready, they are sent to the robot factory.
Inside the factory, the first step is machining the large steel and aluminum parts. Huge CNC machines cut the metal with micron-level precision. This is where the robot's arms and joints take shape. You'll be amazed to know that every joint of a modern industrial robot is designed to rotate thousands of times and withstand millions of repeated movements. Even a small error in one part can cause the entire robot to fail. But the real secret is yet to come. Next come the servo motors, the parts that give the robot motion. A normal motor just spins, but a servo motor always knows its exact position. This is why a robot can work with less than a millimeter of error. These motors are assembled on special production lines. Magnets, copper coils, and sensors are fitted inside them. They are then tested on computer-controlled machines. Then comes the moment when all the different parts are joined together. The robot's main body is prepared. Joints are attached one by one. Servo motors are fitted. Cabling is done. The control unit is installed. Slowly, a lifeless metal frame begins turning into an intelligent machine.
But the factory secret that no one tells you is this. In this stage, the assembly of robots is often done with the help of other robots. Yes, in some highly advanced production centers, robotic arms assemble other robotic arms. It sounds like a science fiction movie, but this is today's reality. And this is where the real birth of the robot begins. Once the hardware is ready, software is loaded into it. It's just like activating the brain inside a human body. Engineers give the robot instructions on how to move, how fast to rotate, how much weight to lift, and with what precision. But even after programming, the robot is not considered ready. Now begins its toughest test. Every robot is run thousands of times continuously. It is made to lift heavy weights, move at high speeds. Some robots are tested in hot environments, others in extremely cold ones. Because the robot that will work in a car factory tomorrow must operate non-stop for years. But the most surprising thing is that some industrial robots can perform thousands of identical tasks in a single day without any drop in accuracy. This capability has completely transformed modern industry. And now comes the stage that often leaves first-time visitors in disbelief. The machine that was once just a frame of metal, motors, and wires is now about to take its first real steps. First, the robot is taken to the calibration station. This is a special area where laser sensors and high-precision cameras measure every movement. Engineers want every joint to rotate at exactly the right angle.
Even a 1 millimeter mistake in its arm can create big problems later on the production line. You'll be amazed to know that some industrial robots can work with an accuracy of 0.02 millimeters, thinner than a human hair. But how does the machine achieve such precision? Behind it is a small device called an encoder. The encoder inside every servo motor constantly tells the control system the exact position of the robot's arm. This information reaches the processor thousands of times per second. The processor then issues the next command. So the robot is not just following orders, it is correcting itself every moment. But the real game is still ahead. Now the robot is taught its actual job. Some will weld, some will paint cars, some will lift heavy engines, and some will handle tiny things like microchips.
Engineers create a digital world for the robot. This digital model is called a digital twin. Before actual production begins, the robot practices its job millions of times in a virtual environment. Yes, you heard that right. Many times, a robot has already performed its job millions of times inside a computer before it starts working in a real factory. This reduces the chance of accidents and increases production speed. But there's another secret most people don't know. Every robot has dozens of sensors inside. These sensors don't just measure position, they constantly monitor vibration, temperature, power consumption, and load. Suppose a motor starts wearing out slightly. A human might not notice it for days, but the robot's sensors detect the change immediately and alert engineers before a part fails. This is called predictive maintenance, and this technology saves factories from losses worth crores of rupees. Now comes the stage where the robot is pushed to its limits. In massive testing areas, the robot is run continuously for days. Its arm is moved up and down millions of times. It is made to lift weights repeatedly. Its speed is increased and then decreased.
Some tests run the robot non-stop for 24 hours, some for 72 hours, and some special models for several weeks. Why? Because when this machine reaches the customer, it will be expected to work almost non-stop for years. But the factory secret no one talks about is this. Just making the robot strong is not enough. It must also be made safe. Imagine a 6-axis industrial robot lifting 200 kilos at high speed. What if it loses control? That's why modern robots have multiple layers of safety. Emergency stop systems, torque limiters, safety controllers, laser scanners, and advanced vision systems. If a human suddenly enters its work area, some robots can stop within milliseconds. But the story gets even more interesting, because the new generation of robots don't just follow commands. They can also learn. Artificial intelligence and machine vision have changed the world of industrial robots. Now, robots with cameras can recognize objects, understand their shape, determine their position, and adjust their arms accordingly. Earlier, a robot was programmed for only one task. Now, advanced systems can perform multiple types of work. This is why factories worldwide are rapidly moving towards smart manufacturing. But you'll be surprised to know that the most expensive part of a robot in the factory is not its steel frame. Often, the most expensive part is its control system and software. The price of some advanced industrial robots can be higher than a luxury car. Then comes the final inspection. Every system is checked once again. Sensors, motors, control unit, safety systems, communication networks, everything. If even one part has a problem, the robot is sent back to the testing area, because there is no room for error here. Once approved, the robot is carefully packed. Its sensitive parts are protected and placed in special containers. Then it heads to its new destination: a car factory, an electronics plant, a warehouse, or perhaps another factory where it will build the next generation of robots. And this is where the story completes its beautiful cycle. Metal from the earth, machines built in factories, robots built by machines, and then those same robots building the next generation of machines. Humans have created machines that have now become the backbone of industry, But one question still remains. If robots are becoming more intelligent, faster, and more capable every day, what will factories look like in the next 20 years? Will humans and robots work side by side, or will most production become fully automated? The answer lies in the future. But one thing is certain. One of the most important forces behind the modern world today is these industrial robots. And the next time you look at a car, a mobile phone, or a household appliance, remember, it's very likely that a robot contributed more to making it than a human. If you love knowing about factories, engineering, and the hidden secrets of the industrial world, don't forget to subscribe to the channel, because next time, we'll take you inside a factory where technology worth millions is built every second.